Hello guys, this is Garv here, and today we are going through the questions on the topic of heat and temperature from the 2005 to the 2009 past year PSLE paper series. I would be going through the answering and annotation techniques in this video. So without any further ado, let's begin. Study the setups A and B below. Setup A and setup B. Okay. Both setups contain a water bath. Both setups have one capillary tubing each, and each setup has a round bottom flask along with a cloth. Now the only difference in both setups is that in setup A, the cloth is at a temperature of 80 degrees Celsius, and in setup B, the cloth is at a temperature of 0 degrees Celsius. So that's the main difference between both setups. Okay, this is a fairly simple question. So which of the following could be observed 2 minutes after the cloth was placed on each of the flasks in setups A and B? Okay, so first we need to understand some key concepts. The first one is that I won't draw it here. Okay. In setup A, the cloth is at 80 degrees Celsius, which is a warmer temperature, and as compared to 0 degrees Celsius in setup B. So we know that when there's a warm temperature, matter expands. Now this matter can be anything, like it can be any object, be it solid, liquid or gas. And when matter expands, it occupies more space. And similarly, for cooler temperatures, when you have a cooler temperature, warmer, not cooler. Okay, cooler temperatures, you have matter that contracts, and naturally anything that contracts would occupy lesser space. So let's look at this setup over here. If I draw the setup for A, we would get this. We have a flask like this, and then on top of this we have this piece of cloth. Now it's not exactly drawn perfectly, but yeah, you get the point. And connected over here is a capillary tube into this water bath. Okay, so this cloth is at a temperature of 80 degrees Celsius, and the gas inside is at room temperature. Now, although they didn't state this, I'm saying it's at room temperature for the sake of explanation, but you can't assume it's at room temperature unless it's given in the question. So just take note of that. Or rather, to make it simple, I won't say room temperature. I'll just say it's at a lower temperature, which is just less than 80 degrees Celsius. Okay, so this gas over here would, when it comes in contact with the warmer surface of the cloth, it gains heat, causing it to expand. So the steps that follow would be this. The cloth loses heat to the glass. Since the cloth has a higher temperature, it is at a higher temperature than the glass, heat is transferred from this cloth, from the warmer region from the cloth, which is a warmer region, to the glass, which is a cooler region. So this causes the temperature of the glass to increase. And when this happens, the glass gets warmer. So the glass is warmer. Now this gas over here, when it comes into contact with the warmer surface of the glass, at this point of contact, it would gain heat. So now we have a warm glass surface, and it SFC for short, which is at a higher temperature than the gas. So the heat would be transferred from the region of higher temperature to the region of lower temperature, which is from the glass surface to the gas. And when this happens, the gas will gain heat. Now if we just say the gas will gain heat, that's incomplete. We must specify from where. What is the source of heat? And in this case, since the gas is in contact with the glass surface, we would say the gas will gain heat from the warmer glass surface. And over here we said that when the temperature increases, when the temperature of any matter increases, the matter will expand. So over here, the gas will expand. Wait, I forgot this point. The temperature of the gas will increase, and when the gas gets warmer, it will expand. And we said that when any matter expands, it occupies more space. So this will cause the gas to occupy more space. So this gas inside the flask, when it occupies more space, it would tend to move down into the capillary tubing. Here you have water. So when this gas moves down, it will push against this water. Not you can't say push, you would say it would displace the water to make space for itself, and eventually this gas would escape out of the capillary tubing as in the form of bubbles. So remember, if you have any gas, that is, if you have a region of gas next to a region of water, and that gas is pushing against the water, you would say that this gas is displacing the water to make space for itself, to make more space for itself, right? So when gas expands, it occupies more space, so it would displace the water to make space for itself, and as a result, it escapes in the form of bubbles, which is option 3 and 4. Option 1 and 2 would be incorrect for setup A. Now if we look at setup B, I'll redraw the figure. If we look at setup B, we have this flask, and this piece of cloth, and then we have this water bath. And now this water bath contains water, as the name suggests. Just give me a second. Yeah. So this water bath contains a capillary tubing. This setup contains a capillary tubing which is immersed inside this layer of water, and you have water inside the capillary tubing up to some height. So the cloth is at the temperature of 0 degrees Celsius, and over here the glass, this glass surface and the gas is at a warmer temperature. So the temperature of the cloth is lesser than the temperature of the glass. So now we know that temperature that heat is heat. We know that heat travels from a region of higher temperature to a region of lower temperature, which in this case would be from the glass to the cloth. So this causes the warmer glass to lose heat, and when this happens, the temperature of the glass decreases. And now you have the glass. Now if we look at the glass and the gas layer interface over here, the glass and the gas interface, just at the point of contact between these two materials, the glass is at a lower temperature as compared to the gas. So naturally, again, heat would travel from a region of higher temperature to lower temperature, which would be from the gas to the glass. So this causes the gas to again lose heat, and its temperature falls. Now when the temperature falls, it gets cooler, and any cooler object, any cooler piece of matter contracts. When matter loses heat, it contracts. So this would cause the gas to contract. And when any matter contracts, it occupies lesser space. So if the gas was let's say occupying this full container, it would now occupy a lesser amount of space because of the fact that it's contracting. So when the gas contracts, there would be more space for the water to occupy. So in this case, we would say that when the gas contracts, the water occupies the space previously occupied by the gas, causing the water to get displaced upwards into the capillary tubing. So the water would start rising upwards to occupy the empty space previously occupied by the gas. So the water level inside the capillary tubule increase. So therefore the option is either the first one or the third one, where water rises up the capillary tube. And since for option 3 both the observations are correct for A and B, the answer would be 3. So that was the question for this video. I hope you guys found this pretty helpful, and if you did, be sure to click on the subscribe button and the bell icon to be notified whenever I post a new video. If you guys have any doubts, any questions you want to ask, feel free to put them down in the comment section below, and I will do my best to answer them. Moreover, please help me achieve my goal of helping as many people as possible by sharing these videos or my channel to other people you know, so that even they can benefit from it. Thank you.